Hi, okay class, so we proceed with another topics, okay, that important for you to know it, okay. That's why I do this video to get you more understanding about these topics, okay. And okay, this topic is about a Green's theorem, okay, Green's theorem. Okay, so actually Green's theorem actually is a theorem which is relates. Okay, it relates. Okay, I just give you the view what about the Green's theorem. So Green's theorem it relates between a line integral. Okay, so you may refer. Okay, you already learn. I mean, I already upload the slide of line integral, so you may refer to the slides. Okay, around a simple closed curve. Okay, so closed curve. Okay, so means that the curve must be closed. It must be closed loop. Okay, alright. And double integral over the plate region. Okay, over the plate region. So what I want to stress here is actually it's a relation. Okay, Green's theorem will be relate with line and also double integral. So line integral is the new topics lah for you. I mean for this chapter. But for double integral, you already learned it before. Okay, in chapter 2, double integral. So it's a relation between these two integral. Okay, so this is a line integral. So the work done, okay, work done by line integral. And then this is a double integral. Okay, so it's a combination or relation between these two. Okay, that is a will reflect lah to the Green's theorem. So the Green's theorem, okay, I just write down first. Okay, the A stand for either the s dy or dy ds. Okay, it's up to you. Okay, where is fxy is equal to p, and the variable involved here xy lah, of course, plus q j. Okay, so this one is for double. Okay, so yes, Green's theorem is only applicable for double integral. Okay, alright. So when you get the question regarding Green's theorem, means that you already have the idea. It must be a double integral. It cannot be triple. Okay, so this is the formula. Okay, this is the equation for that Green's theorem. Okay, that you will use it. So I give you one example, one simple example here. So the question asks you to evaluate the line integral. Yes, you want to evaluate the line integral, or you want to evaluate the work done. Okay, by using, for example, by using Green's theorem. Okay, Green's theorem. Okay, evaluate the line integral, or maybe some textbook or some question will be asked you evaluate the work done. Okay, by using a Green's theorem. Okay, so here is the equation: x square plus y square dx plus 2xy dy. Okay, alright. So let's say this is the equation. So how to solve it? Okay, first of all, okay, by referring to this theorem or to this equation or to this formula, you can see that you need to know what is your q, what is your p, because from this you need to differentiate it, is it? So you need to know first what is your p, and of course lah what is your q. So okay, you may refer now to this equation. So basically this is what they mean by p and q. P is a for I, so means I here is a x. Okay, for the x, and j is for dy. Sorry, this is dy. Okay, so means that what is your p here? Your p here is x square plus y square. And what is your q? Your q is 2xy. Okay, done. So now you need to find out the differentiation of it. Okay, for dp you need to differentiate with respect to y, and for dq you need to differentiate with respect to x. So what we have here, 2y, and here is 2y. Okay, done. After that, what we do next? just substitute what we have there to this equation. So the equation will be here, this one. Okay, so what is your dq dx? It will be 2y. What is your dp dy? It will be 2y. So you will integrate it. Okay, maybe I just write here dx dy for example. So means that the first limit here, you need to find lah. You need to find the limit. Of course, this is limit for x, and then this is the limit for y. Okay, actually basically they have a continuous. Dia lah lagi ayat somewhere here, tapi saya tak tulis because of what? The information given here is not important for us. Okay, not important for it because of, okay, now you don't need to find the limit actually. For this question, you don't need to find the limit. Why? Because, okay, see carefully here. You already solve it here, right? You can solve it from here. 2y minus 2y. What's the answer? It's 0. It's 0. So it's nothing. They have no variable, no function or no value that you will integrate. So integrate 0, what we have? 0. Yeah. So that's why I said that not important for us lah. Supposedly they have another sentence here, the information, but I didn't write here because of it's not important for us for this question because you already get 0 from here, so no need, nothing to integrate, so no need to find out all the limits here. Okay, so it's easy, right? It's simple, right? You just find out your p, find out your q. Not find out, you just abstract from the question and then differentiate it. After that, substitute back into their formula, so then you will get the answer. Okay, so I give you another one example. Okay, another one example. Example 2. Okay, evaluate the line integral. So basically, actually, for this type of question, you can solve it two ways, by using the line integral itself, or you can solve it by using Green's theorem. It depends on the question. If the question already stated that you need to solve by using line integral, so you suppose need to do it in the line integral way approach. Or if the question has stated Green's theorem, so you need to do approach by using Green's theorem. But if they have no any stated there which method or which approach, so you can, it's up to you, you want to solve it by using which one. And for me, I prefer you to solve it by using Green's theorem. Okay, Green's theorem is so easy, it's simple. Okay, so evaluate the line integral. So xy dx plus x square y cube dy, where is c is the, okay, this is what I mean the extra information lah. Tadi saya tak tulis kan sebab tak perlu untuk soalan tu. But this question I write here, okay, because you need this information later. Where C is a triangle with vertices 0, 0, 1, 0 and 1, 2. Okay, with the positive orientation. Positive orientation. Alright, okay. So, okay, by using Green's theorem, okay, I will solve it by using Green's theorem. So, you need to identify what is your P, what is your Q. Okay, this is your P, is it? XY, and this is your Q. So, x square y cube. So, differentiate P with respect to y, differentiate Q with respect to x. So, this is will be x, this is will be 2xy cube. Okay, done. So now substitute into the equation here. So it will be 2x cubed minus x. Okay, and then dA. So now, okay, obviously lah, from this one you cannot get 0 because this is different thing, is it? 2xy cubed minus x will be different lah, different. So you cannot get 0. So yes, you need to find out the limit here. Okay, how to get the limit? Yeah, this one you need to refer back to the notes or to video that I already uploaded, which is a double integral, how to determine the limits. Okay, how to determine the limits. So this is your, you can get the limits from here. So this is your situation here. It's a triangle. Okay, this is triangle. So the vertices is from 0. So this is a 0, 0. And 1, 0 will be somewhere here. And how about 1, 2? 1, 2 will be maybe somewhere here. Okay, this is 1, 2. So this is the shape of the triangle. So, okay, for example, you want to solve dy dx. Okay, dy dx means you need to draw a vertical line. So you need to draw a vertical line inside this region. So at what point that you enter and at what point you leave, okay, you can write down here is on y equal to 0. And you leave at y equal to, so this one you need to find out yourself by yourself the what we call the limit or the equation of it. So the equation will be, okay, this is y equal to ms plus c, so definitely your c is 0. So find out this one, ms. So how to get your ms here? So yeah, I don't want to explain it anymore, okay, because suppose you need to know it. Okay, I just write down the limit. So suppose the limit is from 0 to 2x. Okay, after that, find out the limit for x. So it's from 0 until 1. Okay, so now you can solve it by yourself. Okay, solve it. So suppose the final answer that you should get is 2/3. Okay, class. So this one is the limit for those yang buat y dx. For those who do it dx dy, okay, for those who do it, so you need to draw vertical line. Okay, vertical line. So it's different lah. Your limit will be different, but the answer must be equal 2/3. Okay, easy, right? So I mean, I think for the Green's theorem is simplest one. Just maybe yeah, you have a little bit difficulties on how to find the limit, but it's not a problem for you because you already done it before in double integral topics. So suppose they have no problem for you to find the limit. Okay, alright, so yeah, that's it only about the what we call about the Green's theorem. So just recall back what we need to know for Green's theorem is this one lah. This one the important part. So you need to know what is your P, how to determine your P, how to determine your Q. After that, you need to differentiate P with respect to Y, Q with respect to X. Okay, and then after that, substitute back into the formula, the equation. And of course, find out the limit. Okay, the limit you will find out by using the previous topic, double integral. Then you solve it. Okay, it's easy, right? Okay. Alright, so we're done for this theorem. So class, we still have another few topics, which is what we are surface integral, what else, divergence theorem, Stokes theorem. But like I said in the early video in the introduction, I just upload or I just do it a few video on a certain topic, such as curl and divergence that have been uploaded already. And of course the Green's theorem, and I have another one video which is a surface integral. So that's video I will proceed the next one, okay, the next week. Alright, dah.